Right, coordinate geometry again. CSEC May 2012, question 5b. Let's look at the question. The line L passes through the points S66 and T0 negative 2. Determine part 1 the gradient of the line L for 2 marks. Part 2 determine the equation of the line L for another 2 marks. Part 3 determine the midpoint of the line segment TS for 1 mark. Part 4 determine the length of the line segment TS for 2 marks. What to think about while doing this question? Again, draw a sketch. This will be helpful. Also, some formulae will be helpful. The gradient of a line M is given by the vertical rise over the horizontal shift. Y2 minus Y1 is equal to X2 minus X1, where X1, Y1 and X2, Y2 are 2 points on the line. The equation of a line is given by y is equal to mx plus c, where m is the gradient and c is the y-intercept. Also, the midpoint formula. The midpoint of a line is given by x1 plus x2 over 2, comma, y1 plus y2 over 2, comma, where x1 and y1 and x2 and y2 are the endpoints of the line segment. Length of a line is given by the difference in the x coordinates to be squared, x2 minus x1 squared, plus the difference in the y coordinates, y2 minus y1 to be squared. We take the square root of that. Now let's get into the question now. The line L passes through the points 6, 6. So 6 along the x and then 6 are going in a vertical direction will give me this point here. Let us call this point S. And then T0 negative 2 means I start at 0. I do not move right or left in the direction of the x-axis. On the x-axis I do not move right or left. That's x-axis, this is the y-axis, but I stay here, and then the y tells me to come down. Negative 2 say come down by 2 units, so this is t. And the first question asks me to find the gradient of the line L, and by looking at this image here, I can see that my gradient is given by, let us move upwards, right? As I move upwards here, 1, 2, 3 units, I could come across by 1, 2 units. So I am seeing this to be 3, 1, 2, 3 over 2. So my gradient could be given by 3 over 2 from this sketch. Using calculation now, y2 minus y1 over x2 minus x1. So this is my x1, y1, x2, y2, right? Notice that if this is x1, the other coordinate point, the y coordinate is y1, and this is x2, so the y coordinate here is y2, not y1 but y2. Let us substitute directly into the formula now. M is equal to y2 minus y1, which is 6 subtract negative 2 over x2 2, which is 6, subtract 0. So this is equal to 6 minus minus 2, chain of signs, 6 plus 2, which is equal to 8, over 6, which is equal to 4 2's 8, 3 2 6, 4 over 3. So this is saying that as I go upward by 4 units, 1 2 3 4 units, I come across by 3, 1 2 3, and I get this point here. What I was saying earlier is that I could go up by 3, 1 2 3, and I could come across by 2, 1 2 3 over 2. But when we examine that, we're not exactly on this point here, right? But I am a bit off from it, so 3 over 2 would not have been the correct answer from this graph, but instead I need to go up by 4 and then come across by 3 to be on that intersection here. Right, so bear that in mind, that you could make an error if it is a bit off. So the gradient here is given by 4 over 3. Let us examine this. I could go up again, 1 2 3 4, and then come across a 1 2 3, and I'll be at this point. Alright, let me just draw it out for you. Right, so that's the gradient there. Change in y, which is 4, over change in x, which is 3, and we get the gradient. Next question. The equation of the line L now. The equation of the line L. So just by looking at this graph again, we can see it cuts at -2. So C is equal to -2, where the line cuts the y-axis. It cuts at -2, and the gradient is given by 4 over 3. So just by working here, I can get y is equal to 4 over 3 by x minus 2, because c is equal to -2, and this here is my equation. Right, using calculation, y is equal to mx plus c. From this, I will using the point 6 6 and gradient of 4 and 3. So 6 is equal to 4 on 3 by 6 plus c. So 6 minus 4 on 3 times 6, 3 times 6 divided by 3 is 2, 2 times 4 is equal to 8, so 6 times minus 8 is equal to c. C is equal to -2. So equation y is equal to 4 on 3 x minus 2. Right, other part of the question now. The midpoint of the line segment TS, and we could see that the midpoint formula is given by the sum of the x coordinates over 2. So we find the mean or the average of the x coordinates, comma, and the average of the y coordinates, comma. So let us find the midpoint of this line now. So midpoint is given by the formula x1 plus x2 over 2, y1 plus y2 over 2, and the two endpoints here are t and s. So I'll write that for you. T 6 6, so this is my x1 y1, and the point 0 -2, and that will be my x2 y2. So x1 plus x2 is 6 plus 0 over 2, and I put a comma, and I take the y now, y1, which is 6, y2 is -2, so 6 plus -2 over 2, 6 over 2. 6 plus 0 is 6 over 2, which is 3. 6 plus negative 2 is 6 minus 2, which is 4 over 2. So the midpoint is 3, 2. 3 on the x, 2 on the y. So this is the midpoint of the line segment TS. So this is 3, 2 here, the midpoint. The other question, the length of the line segment TS. Now the formula for the length of a line is the difference in the x coordinate squared plus the difference in the y coordinate squared. Find the square root of that. Now the length of this line, I could complete this right angle triangle here. I'll show you how that will be. And the blue line from TS, theta S, that's the hypotenuse of our right angle triangle here. So that is given by the vertical change, which is 1, 2, 3, 4, 5, 6, 7, 8. Let's make sure of that. 1, 2, 3, 4, 5, 6, 7, 8. The vertical change is 8. Horizontal change is 1, 2, 3, 4, 5, 6. Right. So this is going to be given by 8 squared plus 6 squared. The square root of that is going to give me the hypotenuse. Right, so let's see how this will fit into the formula now, using the formula. Right, just to give you practice on that. Square root length of a line TS, length of the line TS is equal to x2 minus x1 squared plus y2 minus y1 squared. That's the square root of that. This is equal to the square root of x2, which is 6, y2, x1, sorry, which is 0, plus y2, which is 6, minus y1, which is negative 2, to be squared. The square root of all of this, which is equal to the square root of 6 squared, which is 36, plus 6 minus minus 2 is 6 plus 2, which is 8. 8 squared is 64. Square root of this is equal to the square root of 100. So the length of the line TS is equal to 10 units. So this whole line here is 10. 8 squared. Right, this is really the square root of 8 squared plus 6 squared using Pythagoras theorem. And this here is just a version of the Pythagoras theorem. So what we just did there was we defined the gradient of the line L, and we got the gradient of the line L to be 4 on 3. So the gradient of the line L was found. The equation of the line L, 4/3 x minus 2. So y is equal to gradient, and we look at the point where it cut in the y-axis. The midpoint of the line segment, we got that to be 3, 2, x coordinate 3, y coordinate 2. Right, so it's a coordinate point. Midpoint is a coordinate point. This is the location of the middle of the line segment. The length of the line segment is how long the line segment is, and we got this to be 10 units.